This is the last example for this section of the notes. Okay, we're going to take some series that we're given here and we're going to write them in summation notation and then find our sums. So this one would be an important one to listen to because this one might be a little confusing. So let's go letter A here. We have the series 47 plus 34 plus 21 plus dot 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 all the way up to negative 83. Okay, if we were trying to write this in summation notation, right? So the first thing we typically have here is we have our sigma. Okay, now we can use whatever letter we want. I'm going to go ahead and just use n. I've been using n a lot, but we'll say n equals, okay? Now we're going to find the sum from our first term, right? This is like a sub 1, so this is like our first term. So that's why we have a 1 here. And we're going to find the sum all the way till we get to, whatever term number this is, right? This is a sub 2, this is a sub 3. We don't know what this is. So we're going to have to figure out what term number that is at the end so we can put that on top. Okay, then we're also going to need to figure out what our argument is going to be, or what that expression is. I'll show you where that comes from here right now. What we're going to do here is let's create our T of n equation for this one, just in general terms, right? So if I was going to say, hey, I need to know a sub n will equal my first term, right, 47. Actually, let's write it in general terms first. A sub 1 plus our common difference times n minus 1. So you have to use this formula to help us figure out what this is going to be. Okay, and then we'll use that after we have the formula, we'll be able to figure out what that's going to be. So let's say here, right, if I was just going to write this in general terms, a sub n should equal, my first term is 47. Our common difference, right, it's going down by 13. So it's like we're subtracting 13 each time. So you could either write minus 13 or you could say plus a negative 13. Either way is fine. And we really don't know what n is right now. So we're going to leave that as n minus 1. Okay, so this is like the expression that we could use to find, the nth term. Okay, this right here could be exactly what we want to put in up here. It's totally fine to write that expression in there, but it's kind of messy. So let's just simplify it and then we'll write that in there. If we distribute this negative 13 through here, I have 47. Let's even just turn it into minus now, right? Negative 13 times n is negative 13n. And then negative 13 times negative 1 is positive 13. All I'm doing is simplifying this formula here a little bit. So 13 plus 47 is 60 minus 13n. What we just found here is the actual argument. It's the same thing as a simplified form of the a sub n formula. So I'm going to go ahead and actually write that in up here, right? That's 60 minus 13n. That is the argument. Now, we can still use this expression to help us figure out what a sub n is, or what our n is going to be, right? Because a sub n is negative 83. But we need to know how many terms there are going to be. So let's put negative 83 in down here, right? That's the same thing as a sub n. A sub n is negative 83. So a sub n, we're putting in negative 83. And we're going to take this now, and we're going to say that equals 60 minus 13 times n. And now we can figure out how many terms there actually are. Let's just solve this. We'll subtract 60 from each side. So we now have negative 143 is going to equal negative 13n. Divide each side by negative 13. And we'll find here that there are 11 terms in this series. Okay, so we have 11 terms. This term here, negative 83, is actually a sub 11. So we're finding here, let me get rid of all this stuff that's kind of in the way, the sum from the first term all the way to the 11th term. That's what those numbers mean in the front, remember. The first term to the 11th term of this expression. So now that we have it written here in our summation notation, we can figure out what the sum is going to be. And for that, we'll just use our regular sum equation. We'll say the sum of the first 11 terms is going to be our first term, which is 47, plus our 11th term, our last term there, which is going to be negative 83. And then we're going to multiply it by half the number of terms. We're going to multiply it by 11 divided by 2. So 47 plus negative 83 looks like that would be a negative 36. And we multiply that times 11 halves. So when we do that, let's just reduce it down, right? We got negative 18 times 11. And I believe that would be negative 198 if I can still do mental math. So you can use a calculator, no big deal. But the sum of our 11 terms in this series is going to be negative 198. And that is our final answer here. Okay, so our second problem there, we've got 3 plus 10 plus 17 plus ... and then it says 3 plus 7 times the quantity of n minus 1. Okay, so this is the one here where it's asking us to find an expression for the sum. We don't know how many terms there are. We don't know what the last term is, so we can't figure out how many terms there are going to be. So we're just going to write it out in kind of general form. So we do know that there are n number of terms. Okay, which means if we're going to write it out in sigma notation, we're going to draw our sigma first. I'm going to just use n again. You can use whatever letter you want, but since this one's got n in the expression, we're going to use that. We're going to find it from the first term to the nth term right now, because we don't know how many terms there are. Our argument, this one makes it real easy here, because you see this expression that we have is the argument. This expression is the same thing as our, if we said a sub n was going to equal, 3 plus 7 times the quantity of n minus 1, where this would be our first term. And you can see that right here, right? The first term is 3. And then, as we're going through here, you see we're adding 7 each time, which means this is our common difference. And then, we're in first term form. That's why we have the n minus 1 there. So you could take it here and you could just write in there 3 plus 7 times the quantity of n minus 1, right? And that would be the way we could do it. Or if you don't like that form of it there, you could simplify this expression down to, right, we could say 3 plus 7n minus 7 if we distribute the 7 through and then combine our like terms to get 7n minus 4. So you could also have that in there. You could say sigma notation, our sum is going to be from the first term to the nth term of, we've got 7n minus 4. Both of those are correct for your summation notation. Hopefully that makes sense. If we want to find the actual sum, right, we need to know, in this case here, this is like we did in the H10-4 notes at the beginning, right? The sum of n number of terms, we're going to do our first term, which is 3, plus our last term, which ends up being 7n minus 4, times half the number of terms. So we just take this now and we'll simplify it down. We'll get here 7n minus 1 times the quantity of n divided by 2. We'll distribute that through, and we got 7n squared over 2 minus n over 2. And if it's me, I'm just going to leave it like that there. So we have the sum here is going to equal 7n squared over 2 minus n over 2. Now we can take it here and we can check it if we wanted to. We could say here, let's find the sum of the first two terms, right? The first two terms in this are 3 and 10, which the sum is 13. So if I plug a 2 in here, I should end up with 13 as the answer. Let's see. Sum of the first two terms is going to be 7 times 2 squared over 2 minus 2 over 2. Well, what we'll get here is 2 squared is 4. 4 times 7 is 28. Divided by 2 is 14. So this simplifies to 14. 2 divided by 2 is 1. 14 minus 1 is 13. So we know that our answer is correct. So here is our summation notation. It could be written like this, or it could be written up here like we had originally there before we simplified it. Okay, and then it equals our sum expression right there. Okay, so don't be too totally discouraged. I'm not going to make you do this one a whole lot there if you think that was kind of confusing and hard. Okay, but we do need to become comfortable with this one over here. So there are some practice problems, number 6 from your homework there, and I've actually made a couple more practice problems for you that you can do at your leisure. If you feel like you need more practice, do them. If you feel like you got it, then don't do it. It's up to you. All right, questions? Reach out to your teacher. Thanks for watching.